Okay guys, welcome to the second video of the nature of the roots. If you understand everything we discussed on the first part or on the first video, please note that the rest becomes 10 times easier. So what we're going to do is that remember we talked about the discriminant. So now I'm going to show you how to calculate the nature of the roots. So we're going to do multiple examples on this video. Let's start with the first one. Example number 1. Let's determine the nature of the roots for this equation. Let's say I have x squared plus x plus 1, and let's equate this to 0. So first thing first, number 1, you need to find the discriminant. Remember that the discriminant is equals to b squared minus 4ac. So from this equation, you just have to determine the value of a, the value of b, and the value of c. So from this equation, the value of a is equal to 1, because remember the value of a is the coefficient of x squared. So the number that is in front of x squared, we have an invisible 1 here. So the value of a is 1. The value of b is the number in front of x, which is also 1, and the value of c is 1. So therefore the discriminant will be equals to, where there's b we put 1 squared minus 4 into where there's a, I'm going to sub in 1, and where there's c we put 1. Therefore this will give us 1 squared, it's 1 minus 4. Therefore your delta will be equals to -3. Okay, so guys, let's check. Remember that -3 is less than 0, right? It's negative, so this tells us that our delta is less than 0. So if the delta is less than 0, let us determine what? Let us determine the nature of the roots. So if delta is less than 0, therefore the nature of the roots, we're going to say it's a non-real. It's a non-real. This is the nature of the roots. Let's go back to our table. So we said that if the discriminant is less than 0, we're going to have what? A non-real roots. So now we have the nature of the roots. We need to determine the number of real roots. The number of real roots. How many real? The number of real roots. Remember, we don't have the x-intercept, so we have 0 real roots, and your graph will look like this. So the value of a is greater than 0. The graph will look like this. We don't have what? The x-intercept on your graph. Your graph will look like your graph will be like that. So let's go to the second example. Okay, let's work on the second example. So on the second one, let's do this one. The second one, we have x squared minus 6x plus 9, and this is equal to 0. So on this one, we need to identify the value of a, we need the value of b, and the value of c. Remember that a is the number in front of x squared, b is the, please make sure that you take b with the sign, c is positive 9. So now our discriminant will be equal to b squared minus 4ac. Now the discriminant is equal to the value of b. We do the direct substitution. Remember guys, it is just a recipe. You just have to plug in your ingredients. So this will be minus 6x squared minus 4, and the value of a, we said it's 1, and c will be 9. So what we're going to do from here is that the discriminant will be, you just have to punch this on the calculator. Minus 6 squared is 36. 4 times 9 is also 36. So it's 36 minus 36. 36 minus 36 is 0. So the discriminant is 0. So now let's go to our map. Let's call it a map. So we said that if the discriminant is equal to 0, what is the nature of the roots? It's what the discriminant is equal to 0. It will have 2 equal roots. So that is the nature of the root. So now what I'm going to show you guys now, you need to move up. So remember, if it is going to be like this, then you move up, you move back. So it tells you that it will have 2 equal roots, and it will be a real roots. So the nature of the roots, we can write it here and say that the nature of the roots, 1, we're going to say it's real. It will have real roots. Right? It will be real roots. So now let's check. It will have what about the delta? So we know that second thing that we can say is that delta is equals to 0. So 0 is a perfect square. What did we say on our map? Remember, we said that if it's a perfect square, it will be rational. It will have rational roots. So it's a perfect square. It will have rational roots. So since it's perfect square, therefore we can say it will have rational roots. Let's try one more example, or we can do 2 more examples to make sure that you guys understand this. So let's try 2 more. On this one, let's take something like this. Let's say you have x squared minus 5x minus 6, and this is equal to 0. So now remember, the first thing is to determine the values of a, the value of b, and the value of c. So delta is equal to b squared minus 4ac, and delta will be, we just sub in our ingredient. So we have this b as minus 5 squared minus 4, the value of a is 1, and the value of c is minus 6. So now your delta will be equal to, just have to use a calculator. You can use a calculator and you'll find that 5 squared is 25. We're going to say 25. The negative will cancel. This will be 25 plus 24, which will give us delta as what? 49. So now, first thing, we can see that the 49 is positive. So it's greater than 0, right? It's greater than 0, and it's a perfect square. You need to understand what is a perfect square. And it's a perfect square. Let me give you guys the list of perfect square. So the list of perfect square are all the numbers that 1 squared, it's 1, it's a perfect square. 2 squared is 4, it's a perfect square. 3 squared, it's 9, a perfect square. So 4 squared, it's 16. So this tells you that, let's say 5 squared, it's a perfect square. 25, 6 squared, it's a perfect square, which gives us 36. 7 squared, it's a perfect square, which gives us 49, and so on. So our perfect square is 1, 4, 9, 16, 25, 36, 49. So those are your perfect square. So we can see that 49 is a perfect square. So since 49 is a perfect square, what we're going to do is that we're going to go to our, we need to go to our map to identify the nature of the roots. So remember, it's a perfect square. If it's a perfect square, we're going to say that, okay, we start here. This is where we start. So it's best to start here. It's a perfect square. It's rational. I'm going to write it down. It's a perfect square. It's a rational root. So let's write it down here and say this. The nature of the roots. The nature of the roots. Number 1, we said it's rational because it's a perfect square. It has rational roots. So the second one, we need to move up on our map. So we start here. We have to move up. We have to move up. So it is positive. It will have 2 unequal roots. Let's go and write the second one. So first, it's rational. 2, it have, we say it have what? Unequal roots. So it have unequal roots. Why? Because the discriminant is not equal to 0. The discriminant is not equal to 0. Let's keep moving. So now from here, we have to move up again. We have to move from this point. We go up. Let me use a different color so that you can see how we move. So from here, we need to move up. we need to move up, then this is where we're going to stop. We can see that it's also a real root. So it is rational, unequal, and real roots. It has real roots. So those are your nature of the roots. Those are the nature of the roots. So now we can do the last one. Let us quickly work on the last one to make sure that you guys understand. Let's say that this will be example 4. This will be example 4. Let's say that on example 4 you have 2x squared plus 3x minus 7 is equal to 0. Don't forget the steps. Don't forget the steps, guys. Remember, when you work on on maths problem, you need to make sure that you follow all the steps. The first steps is to identify the values of a, b, and c so that you don't make any mistakes. So the value of a is 2, which is the coefficient of x squared. The value of b is 3, and the value of c is minus 7. Therefore, the discriminant will be equals to b squared minus 4ac. The discriminant is equal to the value of b. We have the value of b as 3. This will be 3 squared minus 4 into the value of b, which the value of a, which is 2, and the value of c is minus 7. If you punch this on the calculator, you'll have 3 squared is 9, 4 times 2 is 8, 8 times 7 is 56. So the negative cancels. We have this as positive 56. You can use your calculator. Punch that on the calculator. You'll get your answers 65. So now we know that the discriminant is greater than 0 because 65 is positive, but not a perfect square. 65 is not a perfect square. It's not a perfect square. Right. So that now we have this information, it will be easy for us to do what? To determine the nature of the roots. Let's write it here. The nature of the roots. The nature of roots. So let's go to our map. Remember that we said if it is not a perfect square, we're going to start this side. Okay, let's use a different one. We're going to start here. It's not a perfect square, it's irrational roots. It has irrational roots. Let's write it down first. It has irrational roots. This is the first one. Irrational. The roots are irrational. So the second one, if we keep moving up, we start from irrational. Therefore, we move up. We can see that if we stop here, we have 2 unequal roots. So it's irrational, unequal. Right. It's irrational, unequal. Then if we keep moving up, we'll see that it's real. So let's go down there and write it down. So this will be irrational, unequal, and real. Unequal roots, and the last one is real roots. Right. So on our next lesson, we're going to work more on how to prove the nature of the roots. We need to determine the nature of the roots without solving the equation. Then we need to know to work on the ones that you have to expect in an exam. The type of questions that shows everywhere in an exam. Thank you very much for watching. I'll see you on our next lesson.